In this video, we're going to go ahead and do the assembly of our oil pump as well as the final refinements to the individual measurements of the components. So we'll start this by creating an assembly, starting with our gear and shaft here. Then we'll go ahead and import our pump housing as well. And now we can go ahead and begin our assembly of these two components. So the first thing that we're going to do is go ahead and adjust out the hole diameters inside of our housing because we know from the shaft diameter of our gear and shaft component that we're going to want to change those values to 1/2 of an inch. So with those values adjusted, now we can go ahead and mate the gear and shaft to the housing itself. So we'll do that by making the hole location and the shaft concentric to one another. We'll go ahead and reverse the alignment of the mates. And now we have our gear and shaft properly oriented into this pump housing. Next, we'll go ahead and add another part. So we'll pick the pump cover for now. We'll go ahead and mate the bottom surface of that cover to the top surface of our housing, making those parallel to one another and coincident. And from here, we can go ahead and start lining up our bolt holes. And we'll notice that we can make one hole concentric. However, because we have not done our final measurements for where these holes are going to be, we notice the alignment does not allow us to line up these bolt holes properly. So in order to do that, we need to go ahead and refine exactly where these bolt hole locations are in the two individual components. So we'll start with the pump housing itself. So we'll edit this component and we'll open up the original sketch that has these hole locations inside of it. From here, we'll just go ahead and use our Smart Dimension tool to dimension out exactly where the length and width of these holes should be. Also making them perpendicular and parallel to one another. And now that we have the pump housing hole locations finalized, we can go ahead and repeat the same process on the pump cover. Again, we'll just use those same dimensions, 2.20 for the length and 1.86 for the width of our holes. Now we'll just go ahead and make sure that those holes are, again, parallel to one another as well as perpendicular. And then we can move back to our assembly and align our housing to our cover. So trying to do this mate one more time, we'll go ahead and see if we can make those two hole locations concentric. And we can. So now we have the cover properly aligned to the oil pump housing. And from here, we can go ahead and move on to adding our additional components. So we'll start with adding the additional gear that we need. And we're just going to build that off of our original gear and shaft assembly. So to do this, we'll simply remove the shaft from this gear. And to remove that shaft, all we'll do is just create a circle on the top surface of our part and go ahead and just do a cut extrude to get rid of that. Now we'll go ahead and add a hole in the center of the gear. We're going to go ahead and make that a 1/2 inch hole for the inside of this gear shaft. We may change that later on, but for now we'll get started with a 1/2 inch diameter hole in the center of the part. And we can go ahead and save that off. And then we'll move back to our assembly and determine what we need to build next. So the next thing that we're going to want to do is go ahead and give that gear a shaft to sit on. So to do that, we need to gather a few pieces of information from our pump housing itself. So we'll need to build a shaft that has a specific diameter, and we'll determine that diameter by looking at our original sketch on the pump housing. So we can see our original diameter was a 1/2 inch that we changed to this pump housing, and we'll go ahead and use that 1/2 inch diameter for this whole location for now. And we'll just build a 1/2 inch shaft by sketching a hole and smart dimensioning that out to 0.5 inches. Now we need to figure out what the shaft length is going to be. So to figure out the shaft length, we'll just use some of our measurement tools inside of SolidWorks. We'll just measure from the bottom surface to the top surface of our housing where the shaft is going to be located. And we can see we've got a value of 2.16 inches for that distance. So we'll go ahead and make the shaft length 2.15 inches for the extrusion to give a little bit of clearance. And now we have that shaft built out as a component. So we'll go back to our assembly and we'll import our gear shaft as well as the second gear. And we'll put those into position. Again, repeating the same process of making them concentric to one another. And then we'll go ahead and make those two faces coincident with one another. That way we have the shaft pulled down to the proper position. Now that we have our shaft in place, we can go ahead and bring in our second gear. So we'll insert that component and go back to our mates. We're going to make those two components concentric to one another. We'll go ahead and move that gear up into the housing, concentric with the bottom face. And then we'll go ahead and just make those two lobes of the gears tangent to one another. So now we have it indexed correctly so it looks nice in our model. And at this point, we have the main portion of all of the components here in our part. So we're going to do a little bit of final cleanup. We can see one of our hole locations on the housing of this part was partially covered through one of our modeling processes when we were building out the housing. So we're just going to really quickly and easily put another sketched circle on the top of our housing, and we can use that in two different ways. So first off, we need to recreate this hole. Second off, in this housing, this particular hole location needs to actually be an extruded cut down into the body slightly. So we can go ahead and rotate this over and determine how far down we want to extrude that cut. So we'll pick a location that doesn't interfere too far into our body and have that final hole created right where we need it to be. And at this point, we have pretty much everything done. We'll do a couple final cleanups, maybe add a few more fillets to our part. Additionally, we'll go in and just make sure that all of our hole diameters are identical and matching on our housing as well as our cover. And because they are two different diameters, we'll make sure that the housing has one set hole diameter and then the cover has one that's slightly larger to accommodate bolts going into those positions. And we can see here we're just pulling out an exploded view of our part, taking a look at the individual components. And now we'll just go in here and add this final fillet that we'll do as the last portion of cleanup for this assembly. So now that we've got that portion cleaned up, we'll look at our part here in this exploded view. And now we'll just go ahead and bring that back into shape as the part is, and we'll just look at a few of these individual components. So we'll hide off the cover and we can look inside and see our gears sitting there. We can look at that small little gap that we have for the diameter of that gear shaft versus the housing. So we're happy with all of that. And at this point, we have our entire assembly completed and ready to go. The last thing that we'll do here with our full assembly is we'll do a quick comparison to this part in relationship to a scan of the entire pump housing. So we have two different ways we can look at our parts. We can look at them from an individual standpoint with the individual scans that are inside of our part files, or we can take this entire assembly, bring it out as a model, and look at that compared back to an entire scanned assembly of our pump itself. So we'll go ahead and just bring this into another part file. We'll go ahead and import in our full scan of the oil pump. And then we'll just go ahead and do a quick comparison to get a color map of these two parts and see how they deviate from one another. So looking at our part, we can see where we've got a few different high spots and low spots that we can determine whether or not we want to add back in. We can also see how our part has compares to the scan file in overall length and width. And now we're pretty happy with the way that our part looks. So we'll go ahead and finalize this off. And if we need to make any changes at any point, we can. So in conclusion, you can see that even a part like this that has some relatively complex shapes to it and some more simplistic mechanical components inside of it is pretty simple to reverse engineer. Once we break down the process, we look at the core aspects of that part that are essential to us, and then just simply start whittling away at the pieces. When I do this, I really like to take the essential parts first, get all of that aligned accurately as we need it to be. And then past that, start taking care of the easy, basic shapes of the part and whittling it away until we have the exact object that we need as our component. Then we can start building out those components into an assembly. And once that assembly is put in place, we can start refining the part further and further, really driving down where our bolt hole locations are, how all of our various aspects and features of the parts relate to one another. And additionally, you can see that when we do this process, while we did relatively complete scans for the majority of these components, as we saw in the gear shaft portion of this video series, you don't really need the entire part to be able to reverse engineer accurately. As long as you have the key features, the axis for that part, for instance, and some of the core features that need to be replicated, we're able to pretty quickly and efficiently go through and build out a component like that. So thank you very much for watching this video series on reverse engineering a part and creating an assembly out of it. I hope it's been informative, and if you have any questions or any recommendations for videos to do in the future, feel free to contact us here at Go Measure 3D.